So from this relation, you can find the resistance X of this electrolytic solution, right? This. And we know that from this relationship, conductance is reciprocal of resistance. So conductance is equals to 1 upon X, right? So 1 upon X means 1 upon R, right, into AD upon CD, length AD upon length CD. From here, you can find, once you get the value of resistance, right, or if you have the value of resistance, you can find conductance. This is the relation to find conductance and resistance of this electrolytic solution, right? And this is conductance, right? If you just look at this formula that we have derived before, if I apply the same here, conductance is equals to 1 upon rho, right? And this is reciprocal of resistivity is conductivity. So I have taken this conductance is equals to this conductivity, which is your specific conductivity, A upon L, right? So this is your formula in terms of conductivity, right? So we write it as conductance is equals to conductivity, this A upon L. A upon L can be calculated from this conductivity cell. A is the area of cross section of each of the electrodes and L is the length between the distance between the electrodes, right? So this can be calculated, but A upon L is constant for a cell. Whichever cell you take, the value of A upon L would be constant, because if it's the same cell, this area of cross section of electrodes and distance between the electrodes will always remain constant, right? So we say A upon L is constant for a cell, and you can see it's written on the cell, right? This cell constant is always written on the cell because it's a constant value. So we say A upon L is cell constant. We call it as cell constant, right, into cell constant. This is the formula. So if you know the conductance and the cell constant, right, you can find the value of conductivity of the solution, of the electrolytic solution. So this is denoted by C, or sometimes it may also be denoted by G in some of the books. Conductivity is kappa into, this is your cell constant, A upon L. This is the relationship. Now, and this kappa, this is your conductivity or your specific conductivity, right? So we said we'll calculate the specific conductivity. The specific conductivity can be calculated if you know conductance and the cell constant. Now let's see how we will calculate equivalent conductivity. Equivalent conductivity. Once you know the specific conductivity, equivalent conductivity denoted by delta EQ, it's given by, delta EQ is given by conductivity into 1000 upon your concentration, right? This is the formula for equivalent conductivity. If you look in the previous video lecture, we have already done this, derived this formula of equivalent conductivity. So if you know conductivity, right, and if you know the conductivity and the normality of the solution, we know that in case of equivalent conductivity, this is concentration per 1000 centimeter cube or per liter of the solution, grams. See, this is gram equivalents per liter, right? This is your normality, right, upon normality. This is your normality. So once you know the normality, right, and conductivity, you will get, or specific conductivity, you can get the value of equivalent conductivity. Similarly, the molar conductivity would be it's denoted by lambda m. This would be conductivity, specific conductivity into 1000 upon C, right? Where C is number of moles per liter, which is your molarity. This is conductivity into 1000 upon molarity. So in this case, once you know molarity, right, and conductivity, you can calculate the molar conductivity, right? So this is how you do all these calculations, right? But the most important thing is this experiment and the adjustments that we have made in Wheatstone bridge, right? And there is something called as conductivity water. So conductivity water is the electrolytic conductivity that we have got for this electrolyte. This is the conductivity of water plus conductivity of electrolyte. So if you subtract the conductivity of water from this electrolytic conductivity of this electrolytic solution, you get the conductivity of pure electrolyte, right? Or what we can do is we use specialized water, purified water in these solutions that has minimum conductivity of its own, right? That water is known as conductivity water, right? So I hope all this is clear to you. Thanks.